Hello everyone, hope all is well today. My name is Shalamat. The topic of discussion today is going to be side-by-side box plots, or sometimes called comparative box plots. So let's say that we have many groups, it could be two or more, of numerical values that we would like to compare. We'd like to compare the central tendencies, their dispersions, how more or less dispersed the different groups are, and maybe also we could identify within groups outlying values. And so we can use side-by-side box plots to do all of these things. Okay, so let's first of all start with the assumption that we're going to have two or more numerical vectors, and each one contains a particular group of numerical values. So here in my R editor window, I already typed in three commands that will construct three variables called x, y, and z. Each will be a numerical vector that contains a particular number of values, and they'll represent three different groups. Okay, and so I'll submit these commands. Because I'm using a Windows machine, I'm going to submit the commands with Control R, and so as I press Control R, the selected commands have been submitted to the console, and so now X, Y, and Z have been defined. And if you're using a Mac, you're going to press Command Enter to send the commands to the console. Okay, so now to construct these side-by-side box plots, we use the function called boxplot. And then we put in as separate arguments the different groups. And so numerical vectors, x, y, and z, and this creates the side-by-side box plots. Now notice that R called our groups 1, 2, 3. We might want to use nicer names, and so here we'll use the argument called names, and then we'll combine some names using the C function. So one we'll call group, this is for x, group 1, the second one we'll call group 2, this will be for y, and then the third one we'll call it group 3, and this will be for z. Okay, so as we send or submit this command, this will create these side-by-side box plots with the names. Now notice that we have a axis here for a numerical variable. It would be nice to actually label this axis. So maybe these are heights in centimeters, and so I can use ylab and then height, and then I'll write in centimeters. Okay, and so what I'll do is I'll just select the command that I just submitted. I'll put it in the editor window so that you see. And so here we have the box plot, we have our three variables x, y, z, we have an argument called names, it just gives the names of the different groups, and then with a comma we can add in another argument which I called ylab, and this gives a name to the vertical axis. Okay, so this is the side-by-side box plots. Now the box plots that R constructs with this function are use quartiles, which are not quantiles of type 6. That is, these are quartiles. I use a formula that's different than what's given in class. And so we can construct box plot based on quantiles of type 6. We'll need another function, so we'll have to redefine it. One way to do this is to source a file. Okay, so I'll do source and then file.choose. And then as I submit this command, R is going to ask me to where is my file, the file that I want to source. So this will be in my documents, and then I'll go find the function, the file called plots.r. Inside the function, the file called plots.r, we have a function called boxplot with capital P, capital B. And if you enter boxplot with capital B, capital P, you'll see function, if the file has been sourced properly, you'll see function X use method boxplot. So this means that we now have access to the function called boxplot, and it's used in the exact same way as the original boxplot function. Okay, and so we'll have the boxplot of X, Y, Z with the names and the ylab. And then the only thing that's different, so if we go back to the graph now we just constructed, is that the quartiles are based on quantiles of type 6. So this would be using a formula as given in class. Okay. Now I'm going to go through another example. So let's say that we want to construct side-by-side box plots from data that's been imported from a file. And so what I'll do is I'll create a data frame. I'll call it data. I'll use the function called read.table. 3 arguments, so file.choose. This is to force R to open up a window to ask us where is the file. Header equal to true because I'll have names for my columns in the file. And then sep equal to, in quotation marks, I'll have /t, so that it indicates to R that we use tabulations for delimiting the columns. Now R is going to ask me where is this file. So in my documents I have a file called weather 2007. Okay. Statistical units are actually days of the year 2007, so there should be 365 days that year. If I write in n rows, so number of rows for the data frame we just constructed, there are 365 rows, so 300 each for each day of the year 2007. And then if I display the names of my columns, here we have a few variables which are going to be used to describe the days of the year. And so, for example, one of interest might be the average wind speed in miles per hour. This is the third column. And then what we'll do is we'll construct box plots for the average wind speed, but not for the whole year. We'll do it according to the month. And so there's another variable here called month, which identifies the month of the year. Okay, and so I'll write in box plot. And then I'll use a formula notation. So I want the box plot for the average wind speed. I want this as a function, so use the little tilt near the escape key. And then my variable, which is the month. And so I'm going to have the average wind speed as a function of month. And then I need to indicate to R in the second argument what is the name of the data frame. So in this case it's called data. And so now, as I enter my command, I have the following comparative box plots. So I have the box plot for the average wind speed, but according to the month. So 1 is for January, 2 for February, and so on, until 12 is for December. Now, to make this a bit nicer, we might want to give a label to the vertical axis. This is the average wind speed. And then maybe give a name to the horizontal axis. This is actually the month. Okay, and so what I'll do is I'll copy and paste my command and put it in the editor window and then modify it here. So I have box plot, average wind speed as a function of month from the data frame called data, and then I'll put a ylab. Okay, so this is going to be average wind speed in miles per hour. And then put an xlab. This will be month. Okay. So then as I select my command and submit to the console, I now have labels for the vertical axis and the horizontal axis. Okay. Now again, this is using the original boxplot function with R. Quartiles are not quantiles of type 6. And so because we already sourced a file called plots.r, which redefined the boxplot function, what I'll do is I'll use the new function, capital B, capital P, used in the exact same way as the original boxplot function. But now our graph, you see, looks similar. There's not much change. The only difference is that now the quartiles, the boxes, are based on quantiles of type 6. So this is based on the formula as given in class for the quartiles. All right. So that's it. These are how you construct comparative box plots with R. Have a good day.